percentages and tape diagrams. So we're going to use diagrams to help us understand percentages better. Yay! Today's ICANNs, I can use tape diagrams to solve different problems like what is 40% of 60 or 60 is 40% of what number. So we're going to be digging into this more today. Kind of in a way, a repeat of what we talked about before. So make sure you have today's date, your ICANN statement, and page number, and you're ready to go. So first thing we're going to do is we're going to do a little noticing and a little wondering with some tape diagrams. So if we take a look here, we've got in this orangish color, we've got 80, and then below that we've got another tape diagram broken into 4 parts. Well, I think we can figure out pretty quickly that the entire tape diagram of 80 is 100%, right? So if that's true, what is this? What percentage is this shaded section here? Well, if the entire thing is 100%, we have 3 parts of that 100%. And so three parts, not ports, although I guess it could be a router. No? Anyway. So if we've got all of these 4 parts together making 80, we can think of this a couple ways, right? We can think of this as we can find out exactly what these 3 parts represent total out of the 80. We can also figure out what the percentage of it is here, right? Well, if it's 4 parts together make 100%, we have to figure out what 1/4 is. Well, what's 1/4 of 100? Yeah, 25. So if I've got 25 for each of these blue, that means that it's 75% that's going on here. And we can also figure out what 75% of 80 is really quick, couldn't we? Yeah. So if we know that these are 4 equal parts, we take that 80 and break that up into 20 for each. So if we know that 100% is 80, we know that this percentage it's shaded is 75%. And what is 75% of that 80? 60. How do I know that? Well, I've got 3 parts here, and they make 60 altogether, because out of those 4, or the 80 being broken into 4 equal parts at 20 each, that gives us 60 there. Let's bring back, so oops, sorry, we're bringing back Jada's puppy here. So let's take a look at this. So before we talked about how the puppy weighed 9 pounds right now, and that was 20% of its adult weight. So here's a diagram that Jada used to try and figure out what the puppy would weigh. The adult weight of that puppy is going to be 45 pounds. How can we see that in this tape diagram? Well, if we know that 20% is 9 pounds, we know that it's going to take 5 times as much to equal 100%, right? And if we know that if 1 part is 9 pounds, then the 5 groups together are going to make the 45 pounds that the puppy is going to weigh as a full-grown dog. So what fraction of the dog's weight do we know right now? Well, we can see we've got 1 out of 5, right? So this is 1/5. And we can see that here in the diagram because we have 5 parts, 1 part shaded. So this goes back to that skill, early back in 3rd grade, talking about how, fractions are a part out of some whole. So 1/5 of its weight at this point, it's 1/5 of its weight when it gets to an adult, being 9 pounds right now. Same thing by saying 20%. It's 20% of its full-grown adult weight. So those both kind of come out equivalent. So here's Jada's friend has a dog as well, but this dog weighs 90 pounds. This is a diagram that Jada drew to represent the weight of her friend's dog and the weight of her puppy. So how many times greater is the dog's weight than the puppy's? Well, remember, the puppy is just 9 pounds. How many parts do we have here? Yeah. Altogether, we have 10 here, right? And we have just 1 for the puppy. So the other dog is 10 times as big as Jada's puppy. How would those compare fraction-wise? Well, if I shaded this, it would be 1 part out of the 10, right? So it would be 1/10 the size of her friend's dog, because 1 group of 9 out of the 10 groups of 9 would be 1/10. What about as a percentage? How would that compare as a percentage? Yeah, so we said here it was 10 times greater, right? And here we said that it was 1/10 the weight. And we can say that, if this is 100% and the dog is one of those, or the puppy is one of those, well, take that 100, break it up into 10 parts, that's 10%. So the puppy is 10% of the full-grown dog's weight. So one of the things that you really need to understand from all of this is that fractions and decimals and percentages all come together kind of in this. This is kind of where they all start really binding together as being something that are interchangeable depending on the situation that you're talking about. All right, let's take a look at some money. And I found $5. Noah actually has $5. Elena has 40% as much as Noah. How much does Elena have? And we're going to compare that in a second. Diego has 150% as much as Noah. How much does Diego have? And we're going to compare those in just a second. So see if you can figure out this. What is 40% of Noah's total? Try that again. Okay. We know this whole thing is $5, right? This is what Noah has. Elena has 40% as much as Noah. Okay, so we have to break this up into equal parts. 40% is not going to be very easy to break down in this. We can break this into 5 groups of $1, though, couldn't we? Okay, so if we break these into $1 pieces, that's 100%. How much of a percent is just one of these parts? Yeah, it's 20%, isn't it? So if Elena has 40% as much as Noah, then she has $2. Okay, now using the same sort of thing, if we think about it, this is 20% again, right? This is the 100%. 100% is $5. Well, if Diego has 150%, how much does he have? Well, again, we've got the 100%, right, is the $5. We need 50% more. 50% would be half of the total, right? So that would be one of these parts, 2 of these parts, that's 40%, but we don't need this whole dollar here, do we? Because that would make it into 60%, because that would be 3 parts of the 5 total parts. So since we're just talking about half of this, we need half of $1. So it's actually going to be a little different. So let's draw this out real quick. Okay, I didn't want you to have to wait on me to draw all this. So Diego is the tape diagram here up above, Noah's is below. But Noah's makes $5. So we know that Diego has at least $5, right? And that's right here where those match up. Now I've got 1, 2 full more parts that are the same, but this part here is only half as much. So I know that each one of these is going to be $1. So I've got 5, 6, 7, and then this isn't a whole dollar, because we need just 50% more. So, yeah, $7.50. How is that true? Well, remember that all the parts that we were comparing were the same. We had 5 groups of 1, and the 100% was the total strip here for Noah. If we broke that into equal parts, we could break it into individual dollars. And $1 was then equal to 20%. We saw that from before. But here on this other part, we were able to see that, by using 2 parts at 20% each gave us 40%, and then we just needed half of that 20%, which gave us the 50 cents. All right, one more thing here, staying hydrated. Staying hydrated. During the first part of a hike, Andre drank 1.5 liters or 1 5/10 liters of the water he brought. If this is 50% of the water he brought, how much water did he bring? And if he drank 80% of his water on the entire hike, how much did he drink? See what you come up with. Okay, so I'm going to make this the entire thing. We know that in number 1 here it says if the 1 5/10 liters is 50%, how much did he bring altogether? Well, this is half of this entire 100%, right? So how much did he bring? Yeah, 3 liters, right? Because if half is 1 5/10, that means we have to add another 1 5/10 to get our total that he brought with him. And then if he drank 80% of that total 3 liters, how much do you drink? Well, again, we need to break that 3 up into some sort of easy to use amount. We can see that, we need 80%. So I can just use 1 5/10 for the 50% of that, right? Sometimes really doesn't draw the best. Now, I still have 1 5/10 liters, and I need to break that up. I need 30% of that, right? Because I need to get a total of 80%, because 50 and 30 make 80%. Well, I can break that up into 5 equal parts. What's 1 5/10 divided by 5? Yeah, 3/10. So now I need 3 of these, which makes what? 3 and 3/10 and 3/10 makes 9/10, 9/10, and 1 5/10 makes 2 4/10 liters. And that would be the 80%. I could have divided this back and done the whole thing in just 10%. That would have been one of the ways to solve it out, but I saw that I had 50% here and really just wanted to figure out the other parts there. So it just was simpler for me. Nothing wrong with making it into the individual 10%. So just real fast, when you're thinking about comparing percentages and quantities with those percentages, tape diagrams can help. If you think about what the whole is, 50%, you can figure out what half of that is. Like here, it's talking about needed money to buy a book. 125% of the goal, what of your running goal, what fraction is that? Well, it's going to be more than one whole, isn't it? It's going to be one whole and part of something else, because remember, one whole is 100%. Okay? Same with the other part. If you're talking about the whole to buy the book and you have only half of it, then you can figure out what the fraction is. Since it's 50%, 50% of the whole would be, 1/2. This here is going to be 1 and 1/4, because 25% is 1/4 of a whole 100%. So we were talking today about tape diagrams and how we can figure out both ways of, if we know that 40%, figure out what 40% of a number is, or the percentage of a number, and figure out what the total number is if we know a part is such a percentage of it. That's it for today. Thanks.